Animals are currently used in laboratory experiments to ensure the safety of substances and to carry out biomedical research to improve human health. However, sometimes animal models poorly resemble human diseases or physiology. It's hard for drug developers and biomedical scientists to imagine that high-tech solutions, such as micro-devices and computer models, could one day replace a living being and change this approach to scientific research. Could we show them that organ-on-chip technology, which are devices designed to reproduce specific features of organs in the lab, provide human-relevant information? We launched an organ-on-chip laboratory in the JRC's European Reference Laboratory for Alternatives to Animal Testing, also known as EURL ECVAM, to start investigating the use of these technologies for chemical safety purposes and to help our scientists acquire hands-on experience. We started by creating a state-of-the-art laboratory with all the instrumentation and expertise needed to replicate relevant case studies. The first device we used can integrate multiple organs on the same chip and connect them with a physiological fluid flow. Thus, it allows for the study of organ-organ interactions and complex biological problems. We recently initiated an experimental campaign with such a device, combining liver and brain models to study the neurotoxicity of pesticides. This approach will enable us to reproduce the liver's metabolic function and evaluate the effect of the parent and metabolized compounds on the brain, performing long-term repeated dose toxicity studies. By demonstrating the validity of this technology in real life, we are helping to create a credible option for scientists who are conscious that animal testing is not the way forward. This will also stimulate companies to use organ-on-chip technology and will support its use in regulatory decision-making. Last but not least, this will ensure higher levels of protection for human health and the environment while avoiding animal testing.